my sessions, and you'll get a copy of this recording if it's useful to you.
Okay.
Incidentally, that control panel that you're looking at, the GoToMeeting control panel, you can minimize that so it doesn't take up so much of your screen. If you go up near the upper right where you got two little arrows pointing at one another.
Oh, okay.
If you click on that, it minimizes it, and then if you click on it again, it maximizes it. So it's like a little toggle switch. And
Oh, great.
in general, you don't need the full window up. There's nothing on there that's useful for you. So I always have mine minimized.
Okay.
Okay. So you are going to take the GRE. What's your background? Are you in college right now?
Yeah, so I'm a speech therapy major,
Okay.
and I took the GRE last year, and I did horribly because I didn't study at all.
Okay.
And I have always struggled with math really badly.
Okay.
So it was just bad.
Well, I got good news and bad news. The GRE is easier than the GMAT. At least it is for me. The GMAT is what you have to take to get into business school.
Okay.
And I tutor it also, and it gives me nightmares. It's so hard. Whereas the GRE, at least I find it a whole lot easier, which is a little puzzling because you would think, I mean, the GRE is what you have to take to get into science graduate school.
It's true.
Yeah. And yet here they give the tougher test to the business graduates. I grew up thinking science was at the top of the heap. I guess not. They want the smartest people in business school. But anyway, so I have some practice tests on my computer that I think this one is from the official guide to the GRE.
Okay.
So these are the ones you want to use if possible, as opposed to a Barron's or a Kaplan's or whatever. You know, go straight to the source, the people that put out the test.
Okay.
Excuse me a second. I'm really having bad allergies today. The pollen,
no.
the pollen in the air is just brutal here in Colorado at this time of year. Whereabouts in California are you?
I'm actually in Oregon, but I'm from California.
Oh, okay.
Yeah.
All right. So what I usually do on all my tutoring, GRE or otherwise, is I just go through practice tests and see if you can solve it first. And if you can't, if I need to explain a math principle or something, I will. And I have a drawing tablet hooked up to my, here, let me see if I can show it to you. In other words, with my drawing tablet, it's like me being there with paper and pencil.
Okay.
You can see all of that?
Yeah.
It's Pythagorean's theorem. Okay. And what I'll do on these problems is just draw right on the book. Now, some of these, I apologize for their lack of clarity. But you should be able to read it. If you can't, I can tell you whatever it is you can't read. Can you see that okay?
Yes, I can.
Okay.
Kind of blurry, but make it out.
It gets a little clearer as we go forward.
Okay.
So it's not always this blurry. So what should we do first?
It's up to you. I am really bad at math, so I think we should just start at basics, honestly.
Okay, well, the basics is to draw that circle.
Okay.
As they say, a circle is inscribed in a square. Okay,
yes.
So let's draw the square. Now, does the circle go inside it or outside it?
Outside it. Inside it?
Inscribed.
Okay.
In means inside. superscribed would be outside.
Okay.
Okay. Now, they've told us that the sides of the square are 5, right?
Mm-hmm.
And all 4 of them are 5. Now they want to know which is bigger, the circumference of the circle or the number 15. Well, we need to figure out the circumference of that circle. Do you know what the radius of that circle is?
Is it half? No.
Yep. Yep.
Okay, it is half.
It's half of the diameter.
Okay.
And the diameter goes from there to there. So we know the diameter is 5.
2.5?
2.5, yeah. Radius is really the key thing when you're working with circles or spheres or anything.
Okay.
You never use diameter. You always use radius. They may give you the diameter, kind of like they are in this program. But now we need to know the formula. Let's talk about 2 key formulas. What's the formula for the area of a circle?
For the area of the circle? Oh boy.
I R what?
Squared?
IR squared. You know how I remember that?
How?
Because pi aren't square, they're round.
That's a really good way to remember it.
I'm never going to get it wrong. I'm always going to remember there's a certain ring to it, pi r squared, only it contradicts real life. I suppose unless you're in Chicago, and then they have pizza pies that are probably squared. But in general, pies are round. So, and then the circumference is the other key formula. That's the distance around the outside of the circle. The area is the distance inside the circle. The circumference is the length around it. And it also has 2 pi r.
Okay.
Okay? Those are 2 formulas you definitely want to memorize.
Okay.
Now, they want to know what the circumference of this circle is. So what is the circumference?
C equals 2 pi 2.5 squared.
Just 2.5. Notice the circumference, the r is not squared. Okay? Oops. And as it should be, because when you're squaring stuff, you're getting areas. Mm-hmm. When you're just trying to measure the length of something, then the units are going to be in feet or inches or whatever. They don't actually give us units on this problem because it's not necessary. So do you have a calculator?
Not next to me, but I can grab one.
Well, I tell you what, we don't need one. What's 2 times 2.5?
Oh boy.
How do we get 2.5? We divided 5 by 2.
Yeah.
So what's 2 times 2.5?
5.
Okay. So the circumference is equal to 5 pi. Right?
Yeah.
What is bigger, 5 pi or the number 15?
The number 15.
What's pi equal to?
3.14.
Okay, if I multiply just 5 times 3, I get 15.
Oh, 15, yes.
I got some change. In other words, this is bigger than 3. So yes. 5 pi is the bigger number.
Okay.
So quantity A. Okay, let's scroll down. I tell you what, we'll do 2, but 2 is a little confusing, so let's do 3 and then go back to 2.
Okay.
Okay, now, here the question is, what's the bigger number? Is it, let me turn this on for a moment. Is it 950 raised to the 2000th power, Or is it 10 raised to the 6,000th power? Now, you're not allowed to use your calculator on these.
Okay.
In fact, unless they've changed it, you can't use it on the GRE at all. Is that correct?
Yeah, I don't think I used it.
Okay. They didn't used to allow it on either the GMAT or the GRE, but sometimes they make changes, and I'm not always right on top of them. So, if you could use a calculator, this would be easy, right? You just would take 10 to the 6,000 power, find a number, and then take 950 to the 2,000th power. But given we can't use a calculator, we have to do this problem a little different. First of all, let's talk about what this means. What's 10 squared mean?
100.
Good. What is 100 cubed give you?
1,000.
Well, it gives you 1 followed by 6 zeros.
A million.
Notice what you get. In this first one, we got 1 0. When we multiply that 1 0 by 2, we get our 2 zeros. In the second one, we have 2 zeros after the 1. When we cube it, we're going to multiply those 2 zeros by 3 to get 6 zeros.
Okay.
So that's how you do it. Okay?
Okay.
Now, let's take that. This is a logic problem. It's not, it kind of is a math problem. But so the number on the right is going to be 1 followed by 6,000 zeros. So many that I can't even write it out. I'm going to write it like that.
Okay.
Now, let's look at the number on the left. We can't do much with 950 to the 2,000th power. I don't know anybody that can do that. Okay?
Yeah.
However, as long as we turn that into a number that is like 1,000 or 100 or something like that, we can work with it. Okay? So let's up it from 950 to 1,000. Now, how many zeros is this number going to have? Remember what our formula is.
So 3, no.
Yep, 3 zeros
3
times that exponent.
Okay.
What
so
is
6,000?
2,000. 3 times 2,000 is what?
6,000.
Okay, so this number would also be 1 followed by 6,000 zeros. So which number is bigger?
They're equal. Oh, actually, it wouldn't be equal because we changed it, right?
I upped it. In other words, I had to increase it to get it to be the same size as that one.
So it'd be B.
It would be B, exactly. Okay. So you kind of see here where you kind of almost have to think out of the box. In other words, the only way we can solve this is if we can somehow turn these into factors of 10 or multiples of 10, and we can do that here. Okay, now let's go back and look at the previous problem. Here we have 2 equations, 2 unknowns. If I'm solving, here, let me ask you something. If I have 3 entities that are equal to 0, what has to be true?
That they have to be equal, or all 3 of those have to equal 0?
Not all 3, in fact, just 1. In other words, if I have 0 times 7 times 3, that's 0.
Yeah.
So it doesn't matter as long as one of them is 0. That's what is absolutely necessary. So if you see this first statement, you know that either A, B, or C is 0. And possibly all three. But we don't know that all three. The only thing we know is one of them has to be. So let's look at this second equation. We have U times V equals 0. What does that mean?
That one of those has to be a 0.
Okay. Can both of them be 0 if I look at the first equation?
No.
No, because then I would have 0 equals 14, which is not an equation. Yeah. So, in fact, I know that only one of them is 0 and the other one is not. Okay. Let's let U equal to 0 for the moment. Look in equation number 1. If U is equal to 0, what is V equal to?
14.
Now let's go back and let's let V equal to 0, which is another possibility. When V equals 0, what is U equal to?
7.
Now this is where it gets tricky. So which is bigger, U or V?
V.
No.
Dang it.
Well, this is a very tricky one. This really is. When I first looked at this, I said V also. But notice that this is one solution. This is equally valid. Both of those satisfy both equations. Well, in this solution, U is 0, V is 14, but with this solution, V is 0 and U is 7. So in the second solution, U is bigger than V. In the first solution, V is bigger than U.
Okay.
So what does that tell me?
That both of them are 0?
No, that you can't determine. In other words, since both of these solutions are valid, I don't know. It depends on which solution I'm in. In the lower solution, U is bigger than V, but in the upper solution, V is bigger than U. So since both are possible, then we don't know which is bigger.
Okay.
Okay. And that's why I wanted to skip it, is that one can be kind of confusing. I didn't want to skip it entirely. I just wanted to. I'm a firm believer that the best way to learn anything, whether it's math or not, is start with easy, and then go to medium, and then go to hard.
Yes.
Just like you would learn how to ski. Nobody teaches somebody how to ski by dropping them on the expert slopes to begin with. The person wouldn't learn to ski very well. But if you start them on the beginner slopes, wait till they get a little better. Now you go to the medium slopes, and then once they get better on that, then you can go to the hard slopes. Well, same thing with math, really is. Particularly true with math. You can't really start off with super tough problems if somebody can't do the super easy ones.
Yeah.
All right, so let's look at this one. A set consists of 40 integers. I could write out 40 random integers. There's one. Oops, hold on. Gotta always remember I gotta click this in order to be able to write on this page. So one set of 40 integers might be 1, 7, 9, 14. I'm just picking numbers at random. Dot, dot, dot until I have 40 of them. That is set A.
Okay.
Set B has 150 of them. So B has 150. A has 40. and the number of integers that are in both set in both set A and set B is only 20. In other words, of these 150 integers that B has, only 20 of them match the integers that A has.
Okay.
Okay, but only 20. So, the question is, what's bigger, the total number of integers that are in set A or set B or both? Well, how many integers do we have in set A?
40.
How many integers do we have in set B?
150.
And how many do we have in both?
190. 20 of the same ones, yes.
Well, now it's a question of how we interpret the question. The total number of integers that are in set A, that's 40, or set B, that's another 150. But then there's 20 that are in both.
Yeah.
See, to me, this is worded a little bit ambiguously. Because the total number of integers that are in set B or set A would be how many?
40 or 150?
No, because 20 of them are going to overlap.
Okay, so you take off 20 of them?
From one of them.
So,
in other words, there's 20 integers in set B that match set A.
So 40 and 130?
Yes.
Okay.
That would be 170, which is the same as that.
So that was really...
Or both. Well, that number's only 20. So I guess, I'm not 100% sure of this. I think the answer is equal. But when they say or, usually you add.
Mm-hmm.
So if I say, let me think of another example. Let's say you got 3 wagons. You got wagon A, you got wagon B, and you got wagon C. Wagon A has 100 apples. Wagon B has 50 apples. Wagon C has 25 apples. If I say to you, what's the total number of apples that are in wagon A or wagon B or wagon C, you add all 3 of them together, right?
Yeah.
Well, if I want the total integers that are in set A or set B or both, it's 170. There's only 170. In other words, in those 2 right there, there is exactly 170 different integers, right?
Okay.
I can't add that because those 20 are already in set B. In other words, I subtracted the 20 integers that are in both from that to give me 20. And now I have 20 unique integers. I have 150 unique integers. And these 20 are the same as are in the 150.
Mm-hmm.
So I can't count that. So I'm really, how many integers do I actually have? I have 170 of them.
Okay.
Okay. And again, I don't like this problem because it seems to me it's a bit ambiguous in its wording.
Yeah.
All right. I can I can make this a little bit bigger. I don't know if it's going to help. That's okay. I'll just write over top of it. No,
Okay.
I'll write what the numbers are. Okay, so here we have 2 to the x. And over here we have 3 to the x plus 1. And the only thing we know is x is a negative integer. Okay?
Okay.
So, the only way I really know how to solve these, since we don't know what x is, it could be literally an infinite number of integers. Let's try some.
Okay.
So let's let x be 2. Okay, we're going to start off x equal 2, and we'll see if we can discover something. Excuse me, negative 2. It has to be a negative integer. Okay, so the quantity a becomes 2 to the minus 2. Do you know how to handle a negative exponent?
That would make the answer negative, correct?
Actually not. That's the biggest mistake most people make, is that they think the negative exponent means a negative number. It doesn't. It's the reciprocal. The positive exponent. So it's always this. In other words, if I gave you 2 to the minus 7th, that's the same as 1 over 2 to the positive 7th.
Okay.
With me?
Yes.
So what is 2 to the minus 2?
It is 1 over 2 squared.
1/4.
Yes.
Okay. Now let's check quantity b. Quantity b is 3 to the x plus 1, and x is minus 2. So now that's 3 to the minus 1. What number is that?
1 over 3.
Yes, good. Now 1/3 is bigger than 1/4.
Yes.
So as long as x is minus 2, then quantity b is bigger. So we're going to try a different number and see if we can get quantity a to be bigger, and then we'll know what the answer is.
Okay.
It'll be d. The relationship cannot be determined from the information. But that's generally the secret, is when you try a number, when you pick a number for x, like I did, see which one's bigger. In this case, b is bigger. Now let's pick a different number for x. Over here in blue, I'm going to let x equal minus 3. Okay?
Okay.
So what is a equal to?
The first one. Or quantity a is 1 over 6.
It's 1 over 8. 1 over 2 cubed.
Oh, yes.
1 over 2 cubed. So 1/8. Okay. What's b equal to when we substitute negative 3? So we have 3 to the negative 3 plus 1. That is 3 to the negative 2, which is?
1 over 9.
Which is bigger, 1 over 8 or 1 over 9?
1 over 8.
Yes. So immediately, just by trying two very small numbers, which makes the math easy to do, we've got when x is one number, b is bigger than a, but if I pick another number for x, a is bigger than b.
Okay.
So it's automatically d at this point.
Yeah.
In other words, once you can find two scenarios that give you opposites. Now, had this given me the same b is bigger than a, I might have tried one more number just to see whether it was consistent. And if I pick 3 numbers and all of them give me quantity B is bigger than quantity A, then I'm going to go with that as an answer.
Okay.
But you'll notice that they set these up. This is the way they want you to solve it. And they want you to be able to do it relatively quickly. And the very first 2 numbers I picked solved it.
Yeah.
And just as another one, if I were to set x equals 0, what is any number to the 0th power equal to?
1? No.
Yes, absolutely
Okay.
right. So quantity A would be 1. What would quantity B be?
It would be 3.
Yeah, so again, quantity B is bigger than A. But, oh, I'm sorry. I can't set it equal to 0, x.
Oh, because it's not negative.
It's not negative. 0 is neither negative nor positive. It is an integer, but it's neither negative nor positive. So when we're picking these values for A, we have to stick with the description, absolutely. But we did, the first 2 we tried, so we're fine. You generally want to pick small numbers whenever you're picking numbers like that. In other words, I don't want to pick an x of minus 20 and then an x of minus 30, because now these numbers become awfully hard to figure out what they are.
Yeah.
Okay, let's go down to the next one. Okay. Can you solve that quadratic that has been factored?
Honestly, I don't remember.
Okay, again, I've got 2 quantities multiplied together that equals 0. So the method of solving that is to set each one of them equal to 0.
Okay.
Okay, so if x plus 3 is equal to 0, then x equals negative 3. And if y minus 4 equals 0, then y is equal to 4. So notice that those 2 solutions both work. Well, it's another tricky one, very tricky. It looks like they're the same, right? Because x times y is minus 12, and that's minus 12. So without overthinking the problem, I'm going to say they're the same. However, if we go back and we start thinking about this, that does not mean they both have to be equal to 0. It would be perfectly okay if x was minus 3 and y was 20. This is still a valid equation, right? Now x times y is minus 60. Much smaller than minus 12.
Yeah.
It also would be okay if x was equal to minus 3 and y was equal to plus 3. Now, because that equation is still valid. Okay. However, if this is the actual numbers, then x times y is minus 9, which is bigger than minus 12. So again, I've found possible solutions where some of them give you quantity A is bigger and some of them give you quantity B is bigger.
Yeah.
So you can't tell here. Again, it's D. And this would be a very tricky one. And this would be one I might miss on the test because I'd be going too fast. I'm used to solving these. You're always used to coming up with both solutions. Both solutions work in the equation, but the most important thing to realize is that when two things multiply together to equal 0, only one of them has to be 0. And having x of -3 means I can have y be anything I want, as long as x is -3.
Yeah. Another
very tricky one. Most math students or algebra students would get this wrong. They would just assume that it was -12 and -12.
Okay.
Okay. All right, here's a little bit more of a typical problem. Jeff uses $630 to buy a new guitar. That amount was 15% of his earnings last summer. What's bigger, the amount that he didn't spend on the guitar, in other words, his earnings minus the cost of the guitar, or $3,570? Well, we need to figure out what his earnings are.
Yeah.
Can you come up with an equation to state what his earnings are? This amount was 15% of his earnings. Let's let x equal his earnings. It's always the way to do a word problem, is to define your variable. Okay?
Okay.
Now what can I say? I can say that 15% of x, which is 0.15 times his earnings, is equal to what?
Is equal to 630?
Yeah. He spent 15% of his earnings to buy a guitar that cost $630. Okay, so this equation is true, and more importantly, it allows us to solve for x.
Okay.
So x is 630 divided by 0.15. Now, if I want to divide, since we don't have a calculator, got to do this by long division, but that goes in there 4 times. Hold on a second. That becomes 62, but it's not 42 times, it has to be 420 times. Right? In other words, because it's 0.15, excuse me, it's got to be 4,200.
And that's because you have to move.
You got to move the zeros because of the decimal point.
Okay.
Okay, but how could we prove it? Multiply 0.15 times 4,200 and you'll get $630.
Okay.
Okay, so this does require a little bit of long division involving fractions and stuff. But you can also ballpark it. In other words, when I came up with $420, that didn't make any sense. 15% of 420 would be nowhere near 630. So I was missing a 0. Okay, so I just add the 0, and now that's in the correct ballpark. 10% of 4,200 would be 420. So 15% should be a little bit more like 630, and it is. Okay, so this is what his earnings were. So we figured it out using algebra. Now let's look at the question again. The amount of Jeff's earnings last summer not used to buy the guitar. Well, if his earnings were $4,200 and he bought the guitar for $630, you do that subtraction, you get that.
So it's equal?
Equal is right. Trying to think if there's maybe a faster way to do this, but
yeah.
I can't think of it right offhand. In other words, you have to figure out what his earnings are. The only way to do that is to solve that equation. 0.15x equals 630. How's your arithmetic?
Not that great.
Can you multiply and divide?
Yeah, it just takes me a second.
Okay. That's something I can give you. In fact, let me go there. This is so valuable that you're gonna want to do this. And you can do it on your own. You don't need my assistance to do it.
Okay.
It's a website that lets you practice your arithmetic. Go ahead and yell the answer out loud as quickly as you can, and I will write it in, and we'll see how good you are.
Oh, goodness.
The reason this is so important is because you really cannot do algebra if you don't know how to do these. And what these are they're going to randomly throw addition, subtraction, multiplication, and division problems at you, all of them having single digits, positive or negative.
Okay.
Okay. Let me show you the trick for doing this problem right here. First of all, we're looking at 3 negative signs, right?
Mm-hmm.
Which one is the subtraction sign?
The middle one.
Okay. So whenever you have a subtraction problem that has other negative signs involved, the way you do it is you turn it into an addition problem by just making that an addition. And the moment I do that, I got to change the sign of what was being subtracted.
Mm-hmm.
Instead of subtracting a -8, I'm going to add a +8.
Mm-hmm.
Now, what is -2 plus 8?
6.
Next.
7.
Next.
-1.
Yeah, don't worry. I'm not going to spend the whole session doing that.
Okay. 4. Oh boy. I think it's 48. No.
It's a perfect square. It's a square number. In other words, the one you want to know your perfect squares. Let's go through perfect squares. What's 2 squared?
4.
3 squared.
9.
4 squared.
8.
No.
Nope. 16.
Okay. 5 squared.
25.
6 squared.
36.
7 squared.
49.
So 8 squared has to be a bigger number than 49. Because 49 was 7 squared. So what's 8 squared?
56.
64.
Dang it.
That's okay. Okay, here's what I'm going to do. I'm going to copy this page, and I'm going to put it into the chat section on the GoToMeeting. Open the GoToMeeting window.
Okay.
And click on that link.
Okay, I did.
And it should open in your browser on your end to this same website.
Okay.
Now,
It did.
Now save it. You know how to save it?
Yes.
As a favorite? Okay.
Yeah.
So you can always get back to it. And this is the key page to get back to, because this, like I said, mixes up addition, subtraction, multiplication, and division.
Mm-hmm.
And let me tell you something. You can almost double your score if you were to spend a half an hour a night on your own doing this for like 2 weeks.
Okay.
Because what's going to happen is you're going to get perfect at it. And that's what you need to be, is perfect at it. You can't be 90% good, because that means you're going to be wrong 10% of the time, and you're going to start relying on calculators. And
yes,
that's how that's how that happens. And calculators are great things, but they're terrible in the fact that they let people get high up in math without knowing how to do these flashcards, because you forget how to do it once you do everything with a calculator. So when you go to take a test that doesn't let you use a calculator, you got big problems.
Mm-hmm.
So let me suggest, we'll go ahead and go back to the problems and finish our session today, but let me suggest you put some time in doing these. Okay, as much as you feel you need. But I can tell you this, it's the most important thing. This time that you put in doing this will be more valuable than our tutoring sessions. I mean, that might sound strange to you, but I believe it. I honestly believe a person cannot do math unless you get good at this. And it's pretty much all single digits. Is this 64 or minus 64?
Positive.
Correct. So you know that when you divide a positive by a negative, you get a negative and all of that. Yeah. Okay. So the only thing you really need to do is practice the numbers themselves.
What else should I be practicing during this week, or like where could I practice?
Just stick with this.
Okay, just do this week.
You're not going to believe how much better your math gets once you get excellent at this. And the question is, how long will it take you to get excellent? I don't know. Everybody's different. I don't know. But you'll get excellent pretty fast, because that's the whole purpose of flashcards. I do not know of a better way to memorize something than flashcards. It doesn't matter whether I'm teaching students trig, calculus. There's a lot of stuff to memorize. The best way to memorize anything is with flashcards. And flashcards that you make up yourself. That takes a lot of time to do, though, so this is a reasonable substitute. Okay. Just use it from this site here. Okay. It's that important that I cannot stress it enough. Okay, and I'm going to close out that page. And let's go back and do... Also, I'm going to minimize my GoToMeeting again, which you can do. Okay. You don't need it open anymore. And let's go down to this one. They ask quite a few questions about set theory. Okay. And set theory can be a little overwhelming for people, but it's not really. It doesn't need to be. This set consists of 5 objects. Okay, those could be 5 numbers, they could be 5 different fruits or vegetables, they could be anything. Okay. Okay. There's 5 things in it. So the number of subsets that consist of one object, how many of that are there going to be? Let's just assume that the 5 objects are letters. Okay. How many subsets have exactly one letter that's unique?
They all would.
Well, you can have A, you could have B, you could have C, you could have D, you could have E. So the answer to that is 5, precisely. the number quantity B is the number of subsets that consist of 4 objects. Okay, well, let's start with A, B, C, D, there's 4. I could also have A, C, D, E, there's a different 4.
Mm-hmm.
I could also have I'll start with B, B, C, D, E. Oh, no, yeah, E. I can also have B, if I do that one, that's the same as A, B, C, D.
Oh, yeah.
So I got to find a different one. The question is, can I find less than 4 or less than 5, exactly equal to 5, or more than 5? I think I'm going to find more than 5.
Yeah.
Let's see, because I can also begin with C. C, A, B, E. That's a new one.
Mm-hmm.
Right? That's not the first 2. That's not the third one. Okay. And I can begin with D. That would be D. Let's see. We got 3 that have D. We got 4 that have C. Hold on a minute. And we only have 2 that have D, so I can definitely put another D in there, I think. The question is where. Let's see, it's in the 4th slot, the 3rd slot. I should be able to put it in the 2nd slot. See, these are called counting problems. Where you're just trying to count how many different ways you can arrange these 5 letters. Here's where I was going wrong. There's the 5 letters. Yeah, let's start all over again. I didn't list all 5 letters up top. Okay, so I can have A, B, C, D. There's 1. I can have A, B, C, E. There's 2. I can have B, C, D, E. There's 3. No A in that. I can have A, C, D, E. That's new. That's 4. And I can have A, B, D, E. That's different. In other words, I can have one that starts with A. I can have a second one that starts with A. I can have a third one that starts with A. And I can have a 4th one that starts with A.
Okay.
That covers all the combinations where you're starting with A. And the order doesn't matter here. In other words, A, B, C, D is the same as D, C, B, A. Okay. So, can I find any others? I've got 5 right now. Let's see, if I try to start with B, I could do B, A, D, E. Huh, that's a new one, right?
Yeah.
B-A-D-E. B-A-D-E. Yeah, that's a new one. There's 6. Problem solved. It's quantity B.
Okay.
Okay.
Would you just be able to multiply the 5 and 4 to make it quicker?
Actually, no. It comes down to a combinatorics or permutations. If I'm taking 5 objects and without regard to order, I'm picking 4 at a time, I get 5 factorial over 1 factorial. 5 factorial over 4 factorial. Well, that's precisely equal to 5.
Oh.
So I suspect that I've got one on here that's a duplicate of the other one. This has no A in it. This ACDE, that's new. ABDE is new. And ABDE, no, that's the same as the one above it. BAE is the same as ABDE. So I can only find 5. I cannot find another 4-letter combination that works. Now, this is the hard way to do it, is by counting it. It would be particularly hard if they said there were 25 objects.
Yeah.
We'd still be working on it. And that's the reason this is useful. Have you had combinatorics or permutations yet? Combinations and permutations?
No, I'm just gonna say no.
Okay, well that's something we probably want to talk about. Because you don't have to know about, we don't need to do it today, I'll let you go here in a second. You don't have to know about combinations and permutations. Some of these problems are going to have such small sets, like 5 objects, that you can do it the way I did it. You can just figure out all combinations that are unique.
Yeah.
Okay? It's just that knowing that makes it much quicker, and it allows you to handle more objects. What if they just said 5 objects taken 3 at a time instead of 4?
Yeah.
Then it becomes more than 5, the answer would. And then you solve it by 5 picking 3 out of 5. Maybe a good place to start next time we meet would be with combinations and permutations. It's really rather simple. You just have to memorize 2 formulas and understand what factorial means.
Okay.
Okay? So let's go ahead and stop there. I'll make a note that we made it through question 8.
Okay.
We can pick up next time if you want to go ahead. Let me suggest one other thing here.
Okay.
Communicate. I'm not trying to bypass Wyzant. I certainly don't want to do that. I want to continue running all of our sessions through Wyzant. But if you need to send a message or cancel a session or make a session, the best way to do it is to communicate directly with me rather than having to use Wyzant as a message platform.
Yeah, I like that more.
They don't have any problem with that at all.
Okay.
Let me give you a couple of things. One is this is the email I would like you to use if you need to send me anything.
Okay.
In other words, let's say you go get a practice book from the library and you want to go over some of those problems. Well, you can take your camera out, take a picture of the test page, and send it to my email address. That's @gmail.com.
Okay.
And then I'll be able to bring that up on my screen when we meet.
Okay.
Now, secondly, I want you to when you are scheduling sessions, the best way to do it is to go to my website. I have an automatic scheduler on there.
Okay.
Which shows you my complete availability and lets you schedule a session.
Oh, great. Okay.
Without talking to me.
Okay.
All right. So make note of that website, and here I'll just real briefly show you what you'd need to do. This won't take but 2 seconds. So here's the website. How to schedule, if you scroll down, automatic scheduling, okay?
Okay.
Click on book now. That's how you book an appointment. And when you click on book now, you're interested in a 1-hour online session. It's going to show you a calendar, and it's going to show you all of my availability. If I look at Monday, all of those times are available. You could pick any of those times, and it will schedule a 1-hour appointment for you.
Okay.
And then I get a text message saying, Allie has scheduled a session.
Okay.
Okay.
Great.
So that's the best way to schedule and communicate directly with me. You can use my phone number. You have that.
Yes.
And we'll still go through YZAM.
Okay.
Okay. Allie,
Good.
it was nice working with you, and hope to work with you again.
Yes, I can't wait.
And yeah, and to close out of this, if you drop the go to meeting back down, all you have to do is click on the X of the upper right, and that will log you out of the meeting.
Okay.
Okay? So I'm going to click on that, and I will talk to you again some other time.
Okay.
Thanks.
Thank you.
Bye-bye.